Have you ever looked at some smart gadget and just thought, man, I wish I could build something cool like that? For the longest time, that world felt like it was locked away, just for serious engineers. But what if I told you that's all changing, and that you're probably a lot closer than you think to building your very own connected devices? Let's dive in.
Right? Maybe you've dreamed up a plant that actually texts you when it's thirsty, or a custom light display that dances to your music, or, maybe you just want to automate that one super annoying thing in your house. For years, the gap between having that idea and actually building it, well, it was huge. But that gap, it is closing, and it's closing fast. See, in the past, programming these tiny little electronics was kind of like wrestling with a tangled mess of code. You had to use these complex, really unforgiving languages like C++. For anyone who wasn't a professional engineer, it was a massive barrier, a total non-starter. But today, the path from your idea to a real working thing is becoming a straight line. And this is where our power couple comes into the picture. On one side, we have the ESP32, this tiny but absolutely mighty piece of hardware that is just packed with features. And on the other side, we have MicroPython, a programming language that's famous for its simplicity. You put them together, and what you get is a combination that is completely changing the game. Okay, so to really get why this combo is so special, let's start with the hardware. What exactly is ticking away inside this little ESP32 chip? So the first thing you gotta know is that the ESP32 isn't just a simple processor. No, it's what's called a system-on-chip, or an SoC. The best way to think about it is as a tiny, completely self-contained computer, all crammed onto one single piece of silicon. And that's what makes it so perfect for small, smart gadgets. Now, I know this diagram looks a little complex at first, but it just shows how much stuff is packed into this one chip. You've got the brains of the operation right here, the CPU core. Then over here, you've got the wireless systems for both Wi-Fi and Bluetooth. And all these other blocks, those are the interfaces it uses to connect to the outside world. Let's take a closer look at a few of them. So let's zoom in on the brain of the operation. At its heart is a really powerful 32-bit dual-core microprocessor. Now, having two cores means it's got enough muscle to juggle multiple tasks all at once, like running your code, managing a Wi-Fi connection, and processing sensor data, all without even breaking a sweat. And here we go. This is the ESP32's real superpower, built-in connectivity. Having both Wi-Fi and Bluetooth right on the chip is a huge deal. It means you don't have to bolt on extra modules to get your project online, which saves you precious space, power, and, trust me, a lot of headaches. All this versatility is possible because of the ESP32's really rich set of peripherals. Think of these as the chip's senses and its voice. They're the built-in tools it uses to talk to the outside world. For instance, it's got touch sensors, a temperature sensor, and interfaces like I2C and SPI, which are just standard ways to connect to thousands of different screens, sensors, and other components. Okay, so we've got this incredibly capable piece of hardware. But hardware, well, that's only half the story. Now we need to look at the software that unlocks all that power in a really simple, elegant way. So meet MicroPython. It basically takes the popular Python language, which is already famous for being super easy to read and write, and shrinks it down. It's been re-engineered to be so lean and efficient that it can actually run on tiny computers like the ESP32. It's bringing the power of modern software to the world of physical hardware. And you can see that simplicity right here. This is a complete program to just blink an LED. First, we just import the tools we need. Then we tell the ESP32 which of its pins the LED is connected to. And finally, we have this dead simple loop that just toggles the light on and off and waits for half a second. It's so clean, readable, and incredibly fast to write. So why are so many people choosing MicroPython? Well, it really just boils down to a few things. The simple code means you can prototype ideas unbelievably fast, going from a concept to a working gadget in record time. It gives you super easy access to all those hardware features we just talked about, and there's a massive community out there building things and sharing solutions. So we have the hardware, and we have the software, but how do we get them to actually work together? How do you get MicroPython to run on that tiny little ESP32 chip? Well, the process is called flashing. Now, I know that might sound all technical and intimidating, but it's really not. Honestly, the best way to think about flashing firmware is that you're just installing a tiny operating system. In this case, it's the MicroPython interpreter onto your ESP32. The whole process is really just 4 steps. First, you download the right firmware file for your board. Then you connect the board to your computer. You put it into a special bootloader mode, which is usually as simple as just holding a button while you plug it in. And finally, you run a simple command to copy that firmware onto the chip. That's it. MicroPython is installed. Seriously.
All right, now this is where things get really interesting, because the choice to use MicroPython isn't just about it being easy. It represents a fundamental trade-off that every single developer has to think about.
Which, of course, leads us to a critical question. If MicroPython is so simple and so powerful, why does the old, complex way of using C or C++ even still exist? Why would anyone choose the harder path?
Well, the answer comes down to one thing: raw speed. If you were to benchmark these things, you'd find that languages like C++ are just in a different league. They're compiled directly for the hardware, and they absolutely fly. MicroPython, because it's being interpreted as it runs, is significantly slower in pure execution speed. But here's the key insight. That performance gap, it's a deliberate trade-off. For a huge number of IoT applications, like that smart weather station we talked about, you don't need microsecond-level speed. What you do need is to build, test, and change your idea quickly. The speed of development becomes the most important thing. This table really clarifies the whole trade-off. With C++, you get maximum execution speed, but you pay for it with more complex, slower development. MicroPython completely flips that equation. You sacrifice some of that raw performance, but in return, you get to build and test your ideas at an incredible speed. It's all about choosing the right tool for the right job.
So, after looking at the hardware, the software, and all the trade-offs, what's the big picture here? What should you take away from all this?
Well, we've seen that the ESP32 is a compact, little powerhouse, totally perfect for connected devices. We've learned that MicroPython makes programming that hardware incredibly simple and accessible, even if you're a beginner. And most importantly, we've understood that the choice between MicroPython and something like C++ is a strategic one. It's trading execution speed for development speed.
And this brings us right back to the beginning. The tools to create your own custom smart devices have never been more powerful or easier to use. The barriers are lower than they have ever been. So the only question left is, what will you build?